Good morning all. So today we will learn about simple parameters to calculate the different parameters for simple lifting machine, right? This we already discussed, but for revision we are taking once again. So what parameters we learn, right? First we have seen effort. First thing we have seen what is effort. Effort is denoted by P in our case, and it is nothing but the human effort or load, which is that force which we are applying to lift the load, right? That will be in Newton or kilonewton. Second is load. Load is denoted by W in our case. Load is denoted by W in our case. It is also in Newton or in kilonewton. The weight which is to be lifted is called as load, right? Then we have seen third term, that is velocity ratio. Third term we have seen, that is what? Velocity ratio. Velocity ratio, in short, it is represented by VR, right? Which is defined as the ratio of the distance traveled by effort divided by distance traveled by load. Okay, velocity ratio is defined as the distance traveled by the effort to the distance traveled by the load. Okay, so velocity ratio should be always more than 1, and for a given machine it remains constant. It has no unit because distance both are in distance, so unit will be cancelled. So velocity ratio should be more than 1. Next we have seen mechanical advantage. Mechanical advantage is defined as MA is equal to load W to effort P. So it should be also greater than 1. Load W divided by effort P. Next parameter we have seen, that is input to the machine. So input is defined as the product of the effort into distance multiplied by the effort. So distance traveled by the effort. So it will be in Newton, and it will be in SI unit meter. So it will be in joule, that is work done. So input work done will be in joule, right? Next, what we have seen, output, right? Next, what we have seen, output. So next parameter we have seen, that is sixth parameter, that is our output. So output is equal to W into Y. W is equal to load lifted, and Y is equal to distance traveled by the load, right? W is load lifted and Y is distance traveled by the load, which is also in Newton meter, right? Standard SI unit. Seventh term we have seen, that is efficiency. Efficiency is equal to output divided by input into 100. We will calculate always efficiency in terms of percentage, that's why we have multiplied by 100. So what is output? W load into distance traveled by load. Input is effort into distance traveled by the effort. So what I will do, W by P, I will write this as W by P and this as a X by Y. Okay, X by Y. So what is W by P? W by V is our mechanical advantage, MA, and what is distance traveled by the effort, right, to the distance traveled by the load, that is X by Y which is equal to x by y, which is equal to velocity ratio into 100. So this is our efficiency. So efficiency is equal to output by input into 100, which is equal to w by p into y by x is equal to mechanical advantage divided by velocity ratio into 100, right? So that is our efficiency. Next term we have seen what is our ideal effort. What is our ideal effort? Pi. Ideal effort Pi. The effort which is required to lift the load when there is no friction is called as ideal effort. The effort which is required to lift the load when there is no friction is called as ideal effort, right? In the absence of friction, what is the amount of load, what is the amount of effort required to lift the load? That is called as ideal effort Pi. Okay, so Pi is defined as, ideal effort is defined as Pi is equal to load divided by velocity ratio. Okay, so Pi is ideal effort, W is load, and VR is the velocity ratio. Next term is ideal load. Next term is ideal load W. Next term is ideal load Wi. The load which can be lifted by an effort when there is no friction is called as ideal load Wi. Okay, so from above equation only we can write ideal load Wi is equal to P into velocity ratio. So the load which can be lifted by an effort P, right? The load which can be lifted by an effort P when there is no friction, is called as ideal load Wi. Okay, so Wi is ideal load, P is our effort, and VR is our velocity ratio, right? Next term we have seen is what we have seen, law of machine. Basically, what is law of machine? Law of machine gives the relationship between the effort applied and the load to be lifted, right? Effort applied and load to be lifted मतलब है relation, that is called as law of machine. That is called as what? Law of machine, right? So that is called as law of machine. So suppose for example law of machine is given by law of machine. Suppose for example law of machine given by P is equal to mw plus c. P is equal to mw plus c, which is called as law of machine. So this is the equation of straight line, and m is the slope. Here m is the slope, right? P is your y coordinate and w is your x coordinate. So this graph will come as like this. So what is y coordinate? Effort. What is x coordinate? Load, right? So when load is 0, P is equal to c, right? When x coordinate is 0, P is equal to c. So from here it will start, and it is as a straight line. It will be as a straight line, right? So when w is 0, P is equal to c. So this is our c, right? And this is the equation of line. P is equal to mw plus c, बरोबर. So या इक्वेशनचा स्लोप म्हणजे काय? m, राईट? थीटा. सपोज याच्यावर मी दोन पॉईंट्स घेतले. Here it is x1 y1, x1 comma y1. Here it is x2 comma y2. So slope is equal to m is equal to tan theta is equal to difference of y coordinate divided by difference of x coordinate. So y2 minus y1 divided by x2 minus x1. This is will be your slope, right? So what is the meaning of this c? राईट. जेव्हा तुमचा लोड लिफ्टिंग 0 आहे तरी पण तुम्हाला एफर्ट लागतो. सो हा एफर्ट कशामध्ये यूज होणार? इन ऑर्डर टू ओव्हरकम द फ्रिक्शन. सो दिस इनिशियल अमाऊंट ऑफ लोड एफर्ट सी विल बी यूज्ड टू ओव्हरकम द फ्रिक्शन. राईट. ते काय करेल? फ्रिक्शन ओव्हरकम करायला तुमचं यूज होईल. ते दॅट विल बी यूज्ड फॉर टू ओव्हरकम द फ्रिक्शन. ओके. So from this equation you can calculate easily if you know m and c. जर स्लोप माहीत असेल तुम्हाला त्या इक्वेशनचा and c कॉन्स्टंट माहीत असेल तर तुम्ही पर्टिक्युलर लोडला हाऊ मच एफर्ट विल बी रिक्वायर्ड यू कॅन कॅल्क्युलेट. यू कॅन कॅल्क्युलेट फॉर पर्टिक्युलर लोड हाऊ मच एफर्ट विल बी रिक्वायर्ड. राईट. सो यू कॅन कॅल्क्युलेट दॅट. Next term we have seen that is next term what we have seen, that is mechanical maximum mechanical advantage. Maximum mechanical advantage. So we know that mechanical advantage is equal to ratio of load divided by effort. Right. Ratio of load divided by effort. If we see from the law of what? Machine, load is equal to m into w plus c. mw plus c. So from here we can write load divided by, I will take m common. So m plus c by w. I will take w common. So m plus c by w I can write like this. So from this I can write like m plus c by w. Right. So if w is greater, जर लोडची व्हॅल्यू खूपच जास्त असेल तर c by w आपण काय करू शकतो? निग्लेक्ट. when w is greater. जर लोड लिफ्टिंग खूप जास्त असेल तर आपण काय करू शकतो की that ratio we can neglect. So which is equal to 1 by slope. Right. Maximum mechanical advantage is equal to 1 by slope of the law of machine. Right. Equation. Maximum mechanical advantage. Similarly the next term what we have seen is maximum efficiency. Next term which we have seen is maximum efficiency. So next term which we have seen is maximum efficiency. So I request you to note down all these things. Okay. हे numericals मध्ये आपल्याला कामाला येणार आहे. So what is maximum efficiency? The ratio of maximum mechanical advantage to the velocity ratio is called as maximum efficiency. So maximum efficiency is equal to the ratio of maximum mechanical advantage to the velocity ratio into 100 is equal to 1 by m into 1 by velocity ratio into 100. Right. Maximum mechanical advantage is 1 by m and velocity ratio into 100. 1 by velocity ratio into 100. This is our maximum efficiency. Maximum mechanical advantage, maximum efficiency. Okay. Next we have seen very interesting, which is reversible machine and irreversible machine. So what is reversible machine? Reversible machine, when a machine is capable of doing some work in reverse direction, that is if you remove the effort the load should move in reverse direction. That is a reversible machine. Okay. So for example, pulley system, if you are taking water from well, as soon as you leave the rope, that is effort, bucket will fall into the well. Okay. Bucket will fall into the well. It is called as reversible machine. Right. It is called as reversible machine. So what is the condition for reversible machine? Condition is efficiency is greater than 50%. Okay, so efficiency we have seen. Efficiency is output by input, right? So mechanical advantage by velocity ratio into 100. So if this efficiency is greater than 50%, so it is the reversible machine. And the example is pulley system, right? Pulley system, that is the example of reversible machine. Next is irreversible machine. Next is irreversible machine. Okay, so if you remove the load, effort, then the load will not move in reverse direction. Such a type of condition is called as irreversible machine. So what is the condition for irreversible machine? The condition for irreversible machine is efficiency is less than 50%. Efficiency is less than 50%. So here is small assignment for you students. Just find out the example of irreversible machine. Find examples of irreversible machine, and you can message me on WhatsApp after finding, or else you can tell me in next class. Better if you message me in WhatsApp with your name and example of irreversible machine. So keep in mind, this is assignment, so those who will give answers, they will be benefited in marks. Okay, so you can answer me, you can message me and you can answer. Find the examples of irreversible machine. This is the sort of small this is the small assignment for you. Understood? Find examples of irreversible machine. Next thing what we are going to do is we are calculating the friction in terms of effort and load. So we will be calculating friction in machine in terms of effort and load. In terms of effort and load. Friction in machine in terms of effort and load. Okay, so basically we are going to use P is as a effort, right? P of is effort loss in friction, effort lost in friction. Pf is the effort lost in friction. Pi is equal to ideal effort. Pi is equal to ideal effort, right? So P is our actual effort, Pi is effort lost in friction, and Pi is our ideal effort. So effort lost in friction is equal to actual effort minus ideal effort. Effort lost in friction is equal to actual effort minus ideal effort. Okay, so effort lost in friction, Pf is equal to effort lost in friction, actual effort is P minus ideal effort is Pi. So what is ideal effort? We have seen, right? Ideal effort Pi is equal to, see here, W upon velocity ratio. So ideal effort Pi is equal to W upon velocity ratio. Okay, this is the effort lost in friction. Okay. Similarly, we will find out load lost in friction. Load lost in friction. load lost in friction. So what is the load lost in friction? Let W is equal to actual load. W is equal to actual load lifted WF is equal to load lost in friction W is equal to ideal load. So load lost in friction WF is equal to actual load W minus ideal load W minus actual load W, because actual load lifted will be always less than ideal load, because ideal load मध्ये friction नसणार, actual load मध्ये friction असणार, right? So Wi minus W. So this is our load lost in friction. This is our load lost in friction. WF is equal to Wi minus W. Okay, so we have seen effort lost in friction and load lost in friction. So you remember all these terms because these are very important for your numericals understanding purpose, right? For numerical understanding purpose it is very important. So now we will see types of graphs in upcoming videos and some numericals. Okay, we will see types of graph in numerical and upcoming video and numericals. So just remember and practice all these terms so that you will get acquainted with all these terms. And just today's assignment is find the examples of irreversible machines. So for example, reversible machine, I have given you example of pulley system used in well. So let us continue in next video. I will post next video. Okay.